So in the last session, we started matrix, and we have seen how we can create matrix, and we can perform arithmetic operations and multiplication on the matrix. Continuing further, I told you that we'll do some subsetting here. So we know our matrix, right? A, this is matrix A, 1, 2, 3, 4, 5, 6, 7, 8, 9. Suppose I want a matrix of, I want second row, third element. What is second row, third element? Second row, third element, 6. So this is the six. Or I want third row, second element, that is 8. Then I can also extract the whole column. For example, I can say A1. That means it will create, it will extract all the row of that. Suppose I want all the first column. What I will do is, you can see here, this is comma 1, this is comma 2, this is comma 3, and this is 1 comma, this is 2 comma, this is, that is the name that is given. So here it is extracting it, but it is as a row, as a matrix row. So suppose I want mm, I want first two rows and second two columns. Let us say, so A, first two rows I want, comma, uh, column two to three. So first two rows, 2, 3, 5, 6. Next columns, this is 2, 5, and 3, 6. This is subsetting. What we have seen is how to access subset of matrix. We can perform some more equations, some more operations on matrix. Let us say I want the transpose of the matrix. Transpose of the matrix. The simple command here is uh, T. T of A. So what it has done, actually A is 1, 2, 3, 4, 5, 6, 7, 8, 9. Now it is transpose. And what is the transpose of A? A is right. Same 1, 2, 3, 4, 5, 6. That is the transpose. And what I can do further is I can print the dimensions of a matrix, dim of A. I can print number of rows. I can print number of columns of A. So dimensions is printed with dim, and I can also print the length of M. What is the length of M? Sorry, not length of M, length of A. 3 by 3, 9. So similarly, I can have row sums and column sums. So what is our A? Right. So row sum, so what are the row sums? 1 plus 2, 3 plus 3, 6. This is first row sum. Second row, 4 plus 9 plus 6, 15. Third row 15 plus 9, 24. Similarly, we can have call sums of A. What are call sums? Tell me. 5 plus 7, 12, 7, 8, 15, 9, 9, 18. So we can print call. Similarly, we can also write mean of that. Row means and call means. So what is the mean of this? 1 plus 2, 3, 3 plus 3, 6, 6 by 3, 2. So row means of A. So this is 2 and the mean 4 plus 5, 9 plus 6, 15 by 3 is 5. This is 15 plus 9, 24 by 3 is 8. Similarly, you can have call mean, average, right? So I can print 4 by 6. So this is 1 plus 4, 8 plus 7, 15 by 3 is 1 plus 7, 1 plus 4, 5 plus 7, 12, 12 by 3 is 4, 7, 15 by 3 is 5, and 18 by 3 is 6. That is column mean. Similarly, I can also extract diagonal. I don't know why I'm calling this M. So A, all the diagonal elements, 1, 5, 9, it is giving diagonal. Similarly, you can calculate determinant and you can calculate uh, inverse also. Simple command. That's why the R is more powerful. Uh, if it is C, you have to write the logic for the determinant. So I'm not checking it. I don't know now, but I can also calculate the inverse of the matrix. Okay, let us not do this. You can also use solve to find the inverse if it is non-singular matrix. And we can close this with another concept here known as arrays. Arrays are same as matrix, but it is three-dimensional three-dimensional data structure. So till now, if you see vector one dimensional, right? Matrix two dimensional, then array three dimensional. So three dimensional. Now let us see how we can create an array. Again, same. We have a command called array. Just like we have a command matrix, we have a command called array. So we can have not only three, but we can have more than three. Let me correct that rather than see three or more. Because we use only three, I just named it three, but remember we can use more than three also. Right. So the syntax for that is for creation of an array is array. You have to mention the data just like we are given earlier. Then the dimensions will be giving as number of rows, number of columns, and because three dimensional, you have to give another dimension and you can specify the dimension names also. You can specify the dimension names also. So let us create that. So my array, that is my name, I want to give to my array. So you can see the syntax here: data, dimension, and then dimension name that we can use. So array, let us say I want to give, I want to tell one, what we say, 2 by 2, 2 by 2 by 2. That means totally 8 elements. So 1 to 8. And dimensions are 2 rows, 2 columns, 2 this one tables. So you can see here, this is first dimension, 1, 2, 3, 4. First two, that is one array. And beside that, because it is three-dimensional, another dimension is 5, 7, 6, 8. So what? Let me take out another example, and or I can write here. I can do it in different ways. I can do it in different ways. I can write it here. Uh, Array, maybe three rows, three columns, and two tables. So three. So 9, 18 elements, 1 to 18, and dimension is equal to, earlier I didn't write it, I just directly gave. So two, three rows, three columns, and two tables. So this is three-dimensional matrix. So let us take one more example also. We can also give the names. If you see, I have mentioned here row names as a vector of row 1, row 2, row 3. Or let us say I will do one thing here. A. Then column names, call 1, call 2, call 3, and table name, that means here, this one is array. And I created an array called arnamed. So let me print it. What I have done, I have taken 1 to 18 numbers, but here I also mentioned dim name. So so you can see here row 1, row 2, row 3 names are printed. Table 1, column 2, column 3, row 1, row 2, row 3. So this is how we can create arrays from matrix, and you can index them with three-dimensional index, right? Row, column, and table. Mm, So what is that? Array, unnamed. In that, let us say I want second row, second column in the second table, that is 14. And I can have, I want only second row and second column. And I didn't mention that, right? So second row. This is how we use subsetting. In that, we have to mention row name, column name, and table name. So, as in case of the earlier, I can use dim function, then length function. So, let me do that. Let me create a simple table for me. Again, I may want Harry. I think already is there. Okay, ARR. So, what is my mat array? Array, I want 1 to 18, and dimensions are 3 rows, 3 columns, 2 tables. So this is my array. Now what I can do, I want to print the dimensions of array. So it is 3 rows, 3 columns, and 2 tables. And I can also print the length of array. 3 into 3, 9 into 2, 18. And I can also use attributes. That means the names of columns, and so this is attributes. 3 rows, 3 columns, and 2 tables. Then there is one more important function I want you to understand is apply function. Suppose I want to apply a function on each row. For example, apply function. Use it to apply a function such as row sum or mean on a column or a row. So that is the meaning of function. So apply. What is our array? Right? Uh, apply array, and the function I want to apply is the sum, and I want to apply on the rows. So what it has done, sum of all the first rows. How did it has come? All the rows, first row here, first row there. So it is 21, 33, 36, 38, row weather, yeah, 1, 4, 7, 8, 11, 12, 22, 22, 35, 35 plus 16, 51. That is first row. Then second row, this. Then third row, this one. Similarly, I can use apply R, and on rows I'm applying. So one, and I want as mean. So this is mean. And I can also, instead of doing 1, if I give 2, it will give me the columns. So columns 1, 2, 3, uh, 6 kada, 3, 2, 5, 6, 16, 10, 17, 18, uh, 5, 1, 6, 16, 16, 23, 39. So column wise, suppose I want row wise. So apply, sorry, table wise, apply array and table wise sum. I want sum. So first table is 147, 15, 7, 1, 2, 3, 6, 10, 15, 21, 27, 35, 9, 35, 10, 1, 2, 3, 6, 10, 21, 28, 36, 9, 45. This is table 1 sum, this is table 2 sum. So that is apply function, which is there. And you can also use our general function isArray. It will return true if it has this one. So these are the things I wanted to cover on the arrays.